Welcome to qnawire.
Okay, so for this question, we can apply the energy balance equation here, which is E dot in is equal to E dot out. E dot in is the rate of energy transfer into the system. E dot out is the energy transfer out of the system. So if we expand it, we'll have Q dot W is equal to Q dot air minus Q dot out. Q dot W here is the rate of heat transfer for the water, and Q dot air here is the rate of heat transfer for the air. And we know Q dot out is the heat loss rate. Okay. If we expand it, we'll have m dot W times CPW times TW2 minus TW1 is equal to m dot A times CPA times delta TA minus Q dot out. So we know m dot W here is the mass flow rate for the water, and CPW is the specific heat for the water. TW2 is the exit temperature for the water, and TW1 is the inlet temperature for the water. M dot A is the mass flow rate for the air. CPA is the specific heat for the air, and delta TA is the changing temperature for the air. If we do some arrangement here, eventually we have TW2 is equal to M dot A times CPA times delta TA minus Q dot out over M dot W times CPW plus TW1. So we know CPA, which is the specific heat for the air, is given as 1.005 kilojoule per kilogram times degree Celsius, and the changing temperature for the air should be equal to 65 degrees Celsius. Since it enters at 85 degrees Celsius, when it comes out, the temperature dropped to 20 degrees Celsius. And we know the heat loss rate is given as 25 kilojoule per second, and the mass flow rate for the air is 3 kilogram per second. The specific heat for the water is 4.18 kilojoule per kilogram times degree Celsius, and the inlet temperature for the water is 15 degrees Celsius, and the mass flow rate for the water is 2 kilogram per second. So now let's plug in back to the equation to determine the exit temperature for the water, which is TW2 here, should be equal to 15 degrees Celsius plus 3 kilogram per second, and then times 1.005 kilojoule per kilogram times degree Celsius, and then times 65 degrees Celsius minus 25 kilojoule per second, and then over 2 times 4.18 kilojoule per kilogram times degree Celsius. And this will give us the exit temperature for the water is equal to 35 degrees Celsius. So therefore, the correct answer should be B.